Thank you for attending this do-it-yourself garage related to marine solar panel installation. And specifically, I'm going to give you a little bit of tips and tricks. But Eric, part of our team here at Pacific Yacht Systems, is going to be showing you how to do a crimp with what are called MC4 connectors, right? Because it's not a standard type of doing a normal crimp that you might be used to on your boat. So he'll be showing you how to do that. When you're tackling a solar panel installation, I want to remind you that you're thinking that 12 volts doesn't hurt a lot DC because it's 12 volts. But if you're going to be wiring 3-4 panels in series and they're each 22 volts, remember 22 volts plus 22 volts plus 22 volts plus another 22 volts, now you have 88 volts and you're thinking that DC voltage is benign. Let me tell you, it's going to hurt. It's going to hurt really bad. Remember, there's not a lot of potential on 12 volts, but starting at 80, 90 volts DC, that's starting to be, it's going to be a good moment. You won't forget it anytime soon. So make sure safety is paramount, right? We're all here to learn because all of us are here to not be MacGyvers, right? MacGyver just did it. But it's very important that when you're doing all of this, and then we'll be talking about where to put the fuses, make sure you do things right. And you don't point in putting a solar panel on your boat so that you cause a fire on your boat. That's the least thing we want to do. Everything on a boat has to have a fuse. Every single thing, including a solar panel. So we talked in the last presentation about a wide selection of panels, and when you're going to be choosing the panel, you've got to have to figure out what size fits on your boat. And all these websites, including our own, are showing all the different dimensions. And we have what's called a spec sheet, right, with all the different watts, and all these websites are doing the same thing. What does a certain solar size panel do for amount of watts? And so then you can start figuring that out. We talked in the last presentation this is what I call a conceptual diagram for solar panels. And I always emphasize the absolute need to have a controller between a solar panel and your battery. But notice here, this is the key. This fuse here is absolutely essential to make sure that if ever there's a dead short between here and there, that you're not going to lose your boat. And so you're going to fuse that cable depending on the size of cable that is feeding your array. But for the most part, you're probably going to be working in the land of about gauge 10 wire. So the maximum fuse you can put on there is a gauge 30 amp or 30 amp rated fuse on that. Most of us are not going to even have an array connected to a solar panel that's outputting 30 amps. So like on my boat, for example, if I've got a 50 watt panel, I can easily do a 10 amp fuse, and it's more than plenty, but I'll never have nuisance tripping, right? I'm not really there to protect so much. The solar panel will never output more than 50 watts, but my batteries can provide a lot more than 50 watts. So I'm really worried about a dead short with the power of the battery, not a dead short with the power of the solar panels. And this is an example of how you wire 2 solar panels in series. If you were going to wire this solar, you could do like on my boat, I have literally 6 of these installations, panel to controller to batteries, 6 times. And they're all in parallel, but the solar panels themselves are not in parallel to a single controller. Every single panel is wired to its own controller, and every controller is wired to the battery. So what are the things you're going to look for when you're tackling? You need obviously the solar panel, that's an obvious. You're going to want to have what are called these MC4 connectors. You're going to need what's called an outdoor rated cabling, and Eric is going to be showing you that. And if you look at this wire up close and you're familiar with wire gauges, you're going to be like, oh Jeff, that looks like gauge 8. But that's because if you look at the jacket of this wire, it's actually double jacketed almost. It's much thicker jacket than a typical indoor wiring. We talked about this too, the concept of you're going to need to bring that cable inside your boat. but you don't want to bring any rainwater or anything coming inside your boat, so you're going to end up having a clamshell of some sort to bring the cable inside your boat. And then whenever you come inside the boat, and I always emphasize this, make sure that from that entry point, there is a path to your batteries. A lot of times when we're doing Dodger installation, it's very tricky to have a cable come from underneath the Dodger to go back to the batteries. Like on my Catalina, that could never happen. It's impossible. There is no path from underneath the Dodger to the batteries because I don't have a ceiling. I have no lights against the ceiling. It's literally what you see is a hard shell and there's no pathways. So I had to be creative on how do I get wiring from my Dodger area back into my batteries, right? So again, it's all about discovering that route. How are you going to make that happen? You need to have a controller that is sized specifically for the voltage of the array that you have, the battery voltage that you're connecting to, that it's customizable for the right lead acid battery profile that you have on your boat. So you need all those variables when you're buying a controller. That's why there's so many controllers, because there's not one size controller for everything. Everything is custom. Everything is always built for a purpose. Again, the fuse has to be on what, and this is very important. At your peril, connect always, always, always the fuse at an unswitched positive distribution. You don't fall tempted to bring your solar panel to your DC panel and connect it on the load side. If you do that, you're going to be able to disconnect your batteries and your solar panels are going to wire directly your panel. So your panel is going to be energized and you're going to be like, this is crazy. I shut off the water to my home and I have the faucet open and water is flowing. Water can't flow from a faucet if your home is disconnected from the water supply. It's scary. The challenge is if you wire a solar panel directly to a load, a solar panel is not a power supply. It's not able to adjust the voltage quickly and you're going to have voltage spikes. And if you think a voltage spike is not a problem, you're going to be into a world of pain. Nobody wants voltage spikes. Nobody. And that's how electronic or electrical equipment fail, is when they're fed with too high of a voltage or varying voltages that vary too suddenly. Hence, the fuse has to go all the way back to a point that is unswitched. Like your bilge pumps on your boat have to be unswitched. When you shut off the battery switch, your bilge pumps are always connected to the battery. That's called the unswitched distribution. Same thing with a battery charger. All those devices are unswitched. So here's someone, and you'll see there's a bunch of canvas shops, right, at this boat show. And it doesn't matter where you're at, you can actually sew zippers directly onto this white edge of the solar panel. And you'll have your canvas shop either sew zippers, they might sew, they'll do peel and stick Velcro, or they'll even sew Velcro on the underneath, or they're going to actually make holes in the corner and install grommets. You need a way. I've got owners that have a hardtop, and they'll literally screw them down with rivets. They'll actually rivet it down onto the hardtop. However you want to do it is up to you, as long as you're away from the cells, right? You cannot be close to the cell. So you're going to be sort of in between the cell and the edge of the panel on that white strip is where you're going to actually be doing any sort of perforation on the solar panel. If you're fortunate enough to have a hard top, you can actually buy the solar panel with an adhesive behind and you'll be able to literally peel and stick it like a sticker right onto the top of the surface. And why that's nice is because you don't have to worry about any sort of holes onto your hardtop. You don't have to worry about water ingress coming into your hardtop. And hardtops, by the way, are very, very, very expensive. They're crazy expensive. You do not want to damage a hardtop with water ingress. The solar wiring is this here, same picture. The connectors disassembled, and Eric is going to show us how to do that. A little bit about controllers before we have Eric. Again, make sure that you choose that controller based on the battery voltage and the amperage, maximum amperage you're going to have from your solar panel. And if you, by any chance, have more expensive batteries like AGM, gel, or Firefly, or lithium, you need to make sure that you get a controller that is modifiable for that battery chemistry. Now, you can choose not to do that, but you're going to shorten your battery life by taking that shortcut. This 7515 from Victron, we can actually either via Bluetooth or with a computer actually log into it and actually change the profiles for the battery chemistry right into that unit. Unfortunately, all these devices don't have like little buttons on them like your charger so that you can actually change the chemistry. You're going to have to log into the device to do that, or buy one that is specifically purchased. Like for example, Jenison, which is this one right here, Jenison does a controller that you buy from the factory for Firefly. So they're going to actually give you a controller that is specifically built for Firefly batteries. Neatness is key. Very, very important. And with that, I'm going to have Eric take the floor and show you his handiwork. I'm an engineer, he's a real electrician. I do the talking, he does the work. He makes it happen. I'm opening the floor as Eric gets ready. Anybody have any questions?
Can you go over one more time the fuse sizing?
The fuse sizing, it's very important to not have nuisance tripping, right? You never want to be overfused, but you don't want to be so close that you're going to be losing your solar array. So when you fuse something, especially for this reason, you're protecting the wiring, right? So if it's a gauge 10 wire from literally the battery through the controller all the way, and the controller is also rated for 30 amps, and everything about it is 30 amps, then you could put a 30 amp fuse there, no problem. But if you have a weak point in the circuit, and sometimes you bring down the wiring size to, let's say, gauge 14 is sized for 15 amps. So the biggest fuse you can put is a 15 amp fuse on that circuit. Now, if you have a solar panel that's only outputting 5 amps, then multiply 1.5 and put maybe a 7.5 amp fuse on there, and that's also going to give you enough room so that you'd never have nuisance tripping. And with that, I'll invite all of you to come closer so you can see Eric do his handiwork up and personal.
My name is Eric, and today we're going to be doing solar panel MC4 connectors. So, you take the crimp, take your crimpers, insert it into the crimper, grip it down a little bit, take my cable, my stripped cable, about a 1/2 inch, maybe a little more off the end, insert it, and then crimp. After that, always do a pull check. Make sure that you can't pull it off. That's good crimp. And then you take MC4, take your strainer leaf off, sleeve it over top, take the connector, insert it down, and always make sure you hear that click. Tighten up your strainer leaf, all the way down, and then of course, pull check again. And that's not going anywhere.